Hello and welcome back to another full step-by-step PC build guide, and today I'm going to be showing you how to build a PC in Ridge, the brand new 12.6 litre small form factor case from Fractal Design, which is available from today in both black and white, priced at just under $130 US. So let's take a look at the other parts I'm going to be building with today. For the motherboard, I'm going to be using ASRock's B650E PG-ITX Wi-Fi. For the CPU, I'm going to be using AMD's new Ryzen 9, the 7900X. This is a 12-core CPU with a maximum boost frequency of 5.6 GHz. Keeping our CPU cool, I've got a low-profile CPU cooler from Noctua. It's the NH-L12S. For RAM, I've got 32GB of Kingston Fury Beast DDR5 at 5200 megatransfers per second. For storage, I'm going with two Gen 4 NVMe M.2 drives. The first is from TEAMGROUP, and it's the T-Force CARDEA A440 Pro in 1TB capacity, and the second is the Sabrent Rocket 4 Plus in 2TB capacity. Powering the whole build, I've got a 750 watt Platinum SFX power supply from Seasonic. It's the SPX 750. And for the graphics card, I'm going to be using NVIDIA's RTX 3060 Ti. Okay, that's all the parts, it's time to build. I'm going to make a start by preparing the case. As we go, I'll point out the case's main features. To remove our side panels, we've got two captive thumb screws at the back, which we need to loosen. With the thumb screws loosened at the back, we can pull the panel out from the back. And then what we're going to want to do is pull it towards the back of the case, and then it can be lifted away. Same thing on the other side, we need to pull the panel out from the back, then pull it towards the back of the case and lift away. Taking a look at the back of the panels we've just removed, you'll notice there's no dust filters on the back of them. And this particular side panel, you'll notice it has a whole range of mounting holes. These are for the feet of the case, and you've got a few options in this case. You can mount it horizontally or vertically. So I'm going to show you how the mounting works at the start before we completely disassemble the case, because I want to give you a look at what the case actually looks like in each of its different orientations. In the case accessory box, we've got these two feet. If you're going with a vertical mount, you just need this one. If you're going horizontally, you need both of them. We need to use two different screws for securing each of the feet, and if you look at the heads of them, they actually look very similar. So there's two ways to tell them apart. This thicker one over to the left-hand side is the M4 screw for securing the larger foot panel, and it comes in a packet of 4. The thinner screw over to the right-hand side comes in a packet of 8, and it's for securing the smaller foot. First thing to do is set the side panel onto the feet, lining the holes up, and then we can secure the panel to the feet using the larger M4 screws. Then if we turn our panel upside down and take our other foot, you'll notice we've got these 4 elongated areas, and they're designed to fit through the holes here. So it's just a matter of lining things up. There we go. And then we can use two of the thinner screws to secure this to the panel. So all we need to do is put the side panels back onto the case, and this is what the case will look like in the horizontal orientation. So you'd rather have this fabric panel with the I/O at the side rather than at the front. You simply just need to change the orientation that you put the feet on to the panel at the bottom. So you'll notice now the position of the larger foot has moved, and I'll give you a look at a few different angles of what the case looks like with the feet in this position. So I'm planning to install the case in the vertical orientation, so I'm going to go ahead and remove the feet from the bottom. The first step to install the feet in the vertical orientation is to remove the case's bottom panel. It's held on with 2 screws on each side. And with the screws removed, we should simply be able to lift the case up and away from the bottom panel. Then all we need to do is set the bottom panel onto the feet, and you'll notice we've got a Fractal logo at this end, which is going to be at the front, and it's visible with the holes lined up this way. If we turn this round, you'll notice then it's going to block the Fractal logo, and you're going to have this plain white panel. So we're definitely going to want to see the Fractal logo, so I'm going to install it this way round. And then again, we're going to use the larger M4 screws to secure the panel at the bottom to the feet. Then all we need to do is set this back on at the bottom of the case, and this is then what the case looks like in the vertical orientation. The front panel is magnetically attached and can simply be pulled off from the front. The top panel is removed in a similar way to the bottom panel. We've got 2 screws on each side. And then with the 4 screws removed, the panel can simply be pulled off from the top. Now that we've got the panels off, I want to orientate you in the case. So our motherboard is going to go down here, upside down, so top of the motherboard here, bottom of the motherboard here. And the case is compatible with both Mini ITX and Mini DTX motherboards. The Mini DTX motherboard is going to extend up into this top compartment, so if you do want to install it, you're going to need to remove the fan on this side. In terms of air cooler support, the maximum height for CPU coolers is 70mm. Our power supply is going to go here in this removable bracket. I'll show you how to remove it in a minute. And the case is compatible with both SFX and SFXL power supplies up to a maximum length of 130mm. So in the top compartment you can either put an AIO, a GPU, or a combination of the two. Obviously if you go with a combination it's going to come with some limitations. So starting off with the GPU, assuming you're going with an air-cooled build, you can fit an absolutely massive GPU up to a maximum length of 335mm. If you do install an SSD at the front of the case, it's going to reduce that space down to 325mm. In terms of the height of the GPU, without any fans at the top, it's up to 137mm. You'll notice at the top of the case we do have a fan bracket, and the top of the case it is possible to mount up to 380mm fans. If you do go with fans at the top of the case, your maximum height of your GPU is reduced down to 125mm. In terms of GPU thickness, the case will accommodate triple slot cards up to a maximum thickness of 82mm. To get that full thickness, you are going to have to remove the two 140mm fans that are pre-installed. If you do want to keep those in, you're limited to 57mm in thickness. If you're not worried about a GPU and you want to maximize your CPU cooling, it is possible to fit a 280 or 240mm AIO at the top. If you want to combine a GPU with an AIO, you can mount a 120mm AIO on this side, but then your GP length is going to be limited to 175mm. In terms of fan support, we've got two Aspect 14 PWM fans installed on the side of the case, bringing cool air into your GPU. These are standard thickness fans, so if you still wanted to have fans at the side of the case but get a thick GPU in, you could of course install slim fans, although they are going to increase the noise. It's also possible to mount two 120mm fans here if you prefer. The top of the case is removable, so we've got two screws on each corner. And we're also going to need to remove the four screws at the top of the fans. With the screws all removed, the top panel can simply be lifted up and away. Our graphics card bracket is held on with three screws, two on this side and one on this side. So I want to give you an orientation of how this graphics card bracket is going to work. If we turn it over, it's actually got a Gen 4 riser card on it. This end is going to go into your motherboard, and because your motherboard is going to be installed upside down, the PCIe slot is going to be at the top, so this is going to plug into it. And then your graphics card is going to go into here. Whatever you do, don't just try and plug your graphics card into here. In the case accessory box, we've got this little riser card that needs to be plugged into it. So it's going to slot into here. And that's going to give you the extra height that you need to get your graphics card to reach the slots at the top when you're going to secure it. If you try and put it in here, it's not going to be tall enough to go into those slots. Then down the bottom of the case, we've got a bracket for our SFX power supply. So it's held on with two screws at the front and two at the back. With the four screws removed, we can simply lift the bracket up and lift away. Freeing up our case cables, you notice we've got an extension cable for our power supply. It goes to the back of the case. If you do need to move this for any reason, it's held on with two screws, which is going to allow you to free the cable up. The other thing to point out is we do have a locking point down the bottom of the case. So you'll notice we've got some holes at the front of the case for mounting drives, and we can fit two 2.5-inch drives at the front of the case. So you can have one at the bottom here, and then one at the top here. And then all you need to simply do is screw the drives in from the front. Our other drive mounting location is at the back of the case, and we can mount a further two 2.5-inch drives here, and these are definitely going to be easier to secure. All we need to do is line the holes in the back of the drive up with the pins here on the case, and once we're happy they're lined up, it's just a simple matter of pushing them into place, and then we can have another one down below. So again, line things up, and then it's just a simple matter of pushing to secure the drives. The first thing I want to do is install our CPU. So to open the socket cover, we need to push the lever down and out and all the way towards the bottom of the motherboard, and then we can open the slot cover up. We can then set our CPU into the socket with the text the correct way up, lining it up with the notches at the top and at the bottom. We can give it a little gentle wiggle just to check it's fully in the socket, which it is, and once we're happy we can then lower the socket cover down again, and then as we close the lever, the black bit of plastic pops off, and then we can put this into the motherboard box to keep it safe. Next up is installing our M.2 SSD, and we've got one on the front of the motherboard behind this actively cooled heatsink, and one on the back. So we'll start off at the front. So we need to loosen the two screws holding the heatsink in place. And then with the screws loosened, we can lift the heatsink off. We can then set our M.2 SSD into the socket at a slight angle. And then you'll notice when we flatten it down, the same screw that's going to hold our heatsink in place is also going to secure our drive in place. Just before we return the heatsink, we need to remove the plastic protection. And then we can flatten our drive down into place and line the heatsink back up again. Our other M.2 SSD slot is on the back of the motherboard, so we can insert the drive into the slot at a slight angle. We can then flatten the drive down and then use a screw from the motherboard box to secure the drive into place. Next thing is to install our RAM, so we need to open the clips on both slots. We can then line the RAM up with the slot. Once we're happy everything's lined up, it's just some firm pressure at the top and the RAM is going to clip into place. Same thing with our second stick, line it up with the slot. And again, once we're happy everything's lined up, some firm pressure and it's going to clip into place. First step in installing our CPU cooler is to remove these two clips. Next we can add one of these spacers to each corner. Then we've got one of these brackets to go on the top and the bottom, and we'll secure it into place with two screws. Then we can add some thermal paste to the centre of the CPU. It is included with the cooler. Then we can lower the CPU cooler down, lining it up with a bracket beneath. You'll notice we've got some holes in the CPU cooler and they're designed to allow you to pass a screwdriver through. You might just need to line the fan blades up and then you're going to be able to screw the cooler into the bracket beneath. And if you don't have a long screwdriver, there is one included with the cooler. Then we can plug the fan coming from our CPU cooler into our CPU fan header. As well, at this stage I'm going to plug in our 8-pin EPS power cable because it might be difficult to plug it in once we've installed the motherboard in the case. Next we can set our motherboard into the case, lining it up with the standoffs beneath. Then we can secure the motherboard into place using the same screws we used to secure the small foot to the bottom of the case. So with our motherboard installed, I'm definitely glad I installed our 8-pin EPS cable because it looks like it will be much more difficult to install this at this stage. Okay, next thing to do is get our case cables plugged in. Our HDRIO cable is going to go into this header here. So I think I'm just going to route it down from under the CPU cooler and bring it up this way. And then we can get it plugged into the header. Two headers along, we've got our system fan header. So the first thing I'm going to do is daisy chain our two system fans together. There we go. And then that's just going to leave us with one header to plug into the motherboard. And I think I'm just going to try and cable manage as I go. So I'm just going to route the cable down onto the fan and use a cable tie to bring these two cables together. And then I'm just going to tuck the two fan cables in under the heatsink and down and out of the way. Next we've got our front panel connectors and they're going to go into this header here. So into pins 1 and 2 in the top row we've got power LED positive and power LED negative, and then directly next to that we've got our power switch. The header just above that is for our front panel type C connector, and the one just below is for our USB 3.0 header. I'm also at this stage going to plug in our 24-pin power supply cable. I'm then going to use two of the Velcro cable straps that come in the case accessory box to manage these cables just over here. Next we can set our power supply bracket onto our power supply, and then we'll get it secured into place with 4 of the larger screws from the case accessory box. We can then set the power supply back in at the bottom of the case, and then we can secure the power supply down at the bottom with the same 4 screws we removed earlier on. At this stage we can then plug our 8-pin EPS cable into our power supply, and our 24-pin cable I'm also going to route up the side of the power supply and get it plugged in. We're also going to need to plug in a single PCIe cable, so I'm going to plug it in at this stage as well. And what Fractal recommend doing is tucking excess cable down behind the power supply. So I'm going to bring the cable down behind here and start pushing it into the space behind the power supply. The other end of the cable, I'm just going to put our adapter on for our graphics card, which comes in the box with the graphics card. This cable here, Fractal do recommend you manage to the graphics card bracket, so I think it's a good stage to install it. So we just need to open the clip on our PCIe slot, and then we can line our GPU bracket up with the slot. Once we're happy everything's lined up, it's some firm pressure and it's going to clip into place. And then we just need to fasten the bracket into place with the same 3 screws we removed earlier on. You'll notice we've got a cable tie down point for a 24-pin cable just here. So I'm just going to pass a Velcro cable strap through the gap, route our 24-pin cable up into place, and then we'll get it secured into place using the Velcro cable strap. And then we're going to bring the cable extension for the power supply and get it plugged in. And again, we've got some cable tie down points at the bottom to help manage the cables. We're now ready to install our graphics card, so we're going to need to remove the first two expansion slot covers. So I'm just going to lower this little extension bracket down into the case and push it into place. Then all we need to do is lower our graphics card down, line it up with the slot beneath, and once we're happy everything's lined up, it's just some firm pressure and the graphics card is going to clip into place. And then we can secure it into place with the two thumb screws we have removed. Next we can get our power supply cable plugged in at the top. And as Fractal recommend, we're just going to tuck any excess power cable in behind our power supply. At this stage we can set our top panel back into place, and then we'll get it secured into place with the screws we removed earlier on. Okay, so that's the build complete, and I've gone ahead and set the PC up off camera. The reason I've done that is I made a very similar build guide using another ASRock motherboard with exactly the same CPU in the LANCOOL 3 fairly recently. So I'll put a link to that video if you need to know how to install Windows, the drivers, get the BIOS updated and adjust the BIOS settings. Take a look at that video. The process for doing that is going to be exactly the same, and I want to get on to something more interesting in finding out how our 7900X performed in such a small case. So our Ryzen 9 7900X idled at 52 degrees, and during the 10-minute AIDA64 it reached its thermal limit of 95 degrees, running at 4.9 to 5 GHz. The RTX 3060 Ti idled at 30 degrees, reaching a maximum of 71 degrees during the 10-minute AIDA64 stability test. In terms of noise levels, the average noise levels at idle were 44 decibels, while during the AIDA64 stability test the average noise levels were 53 decibels. So one important thing to point out, you'll probably notice during the build that we had a fan on our M.2 SSD heatsink, which is designed for the Gen 5 drives, which do run pretty hot. One issue I had with this was the fan was incredibly noisy. It sounded like a plane taking off next to me, even when I ran it in the silent profile. So for all the thermal testing, I did disable this fan. So the noise levels that I'm giving you are actually the noises of the other fans in the system, and we can't blame that chipset fan for the noise levels. Obviously, when you get a Gen 5 drive, ASRock have some pretty impressive data in their reviewer's guide, which shows this does a great job of improving the performance of the Gen 5 drives, which run fairly hot. As I had a Gen 4 drive, I didn't need the extra cooling, so decided to save myself the noise. So in terms of the temperatures, really the PC hit that thermal limit of 95 degrees really quickly. And I don't think this would be a great way to run this system in the long term. And it's not a big surprise, I put a really powerful, difficult to cool CPU into a small system with a really small low profile cooler. So the next thing I wanted to test was what would happen if I enabled eco mode. So enabling eco mode, the main difference was there was a massive reduction in our CPU temperature under the AIDA64 stability test, and it came down from its thermal limit of 95 to 70 degrees. This was at the cost of clock speeds, which reduced to around about 3.1 GHz from 4.9 to 5 GHz. There also was a significant noise saving of 5 decibels under load. So the PC was definitely cooler and quieter, but at those clock speeds the performance were likely to take a significant hit. So I ran Cinebench R23, and with our PC in the first configuration we got a multi-core score of 27,242. Enabling eco mode, our score fell by 11% to 24,185. And you can see there our core clocks were running at 4.2 to 4.3 GHz compared to the 4.8 to 4.9 GHz we were getting in the default configuration. So I did try out a few other configurations. So with PBO and TJ Max limited to 85 degrees, our score fell by just 2.5%. and with our core clocks running at 4.6 GHz. Further reducing our TJ max to 75 degrees, our multi-core score fell by 6.6%, with the core clocks running at 4.4 GHz. So I think the profile limiting the temperatures to 85 degrees was probably my favourite here. We're only sacrificing 2.5% of performance, but bringing temperatures down by 10 degrees. And obviously if I had to spend a bit more time and fine-tune things, I'm sure I could have come up with an even better profile. Whether it's a good idea to put a 7900X in this case, well, it probably isn't. I think if you're going to spend that money on such a powerful CPU, you don't really want to be limiting the performance, and in fact you might want to probably overclock it and get a little bit more performance. So a bigger case with a 360mm IO is probably what you want for this CPU. But it was fun to test it out, and I just wanted to see how much we were limiting the performance by putting it in this case. In terms of the GPU performance, it performed really well, and it was very similar temperatures to what I've got in other small form factor builds, and not that far behind what I was getting in a large ventilated case. So the GPU is pretty good. There is significant limitations on the CPU, and probably go with a CPU that doesn't run quite as hot. What I'm planning on doing now is a full case review. I'll put a link to that video in the description. So if you are thinking of doing a build in that case, you probably are going to check out the review to find out what I've thought about this case. So if you do enjoy this video, please remember to give it a thumbs up. And if you're not subscribed to the channel, please hit the subscribe button as well. Thanks for watching.